we wanted to start off with just going over some of the principles of research because they apply to both database and non-database tracks. And we thought this was important because understanding the principles will have you sort things through, because in the afternoon, you'll actually be designing your own study. Alright, so what is research? Research is really, the key word is systematic. It's a systematic investigation. And it's a systematic investigation into the study of material sources, anything that's related to that, with the goal of discovering something new or collating old information and reanalyzing it to give new information, new meaning. So the key words in here is systematic investigation. So research is basically what we do when we have a question or a problem that we want to resolve. We may already think we know the answer to a question already. We may think the answer is obvious, maybe common sense. But until we subject the problem to rigorous scientific scrutiny, this knowledge remains little more than guesswork and maybe as intuition as well. So the key thing is that research itself has to be something that is a systematic. In other words, you should be able to repeat it and you should be able to get the same results each time. So the first and most important thing that one does for research is to formulate your question. And then you can figure out how you're going to answer it. You can look to see how others have answered it, and how does your proposal fit in with what others have done. How will you know when you have answered it, right? And then, when you have figured out these parts of your question, then you can finally present your answer. And so, this is a systematic approach to generating your question, and then figuring out how to analyze it, which will be the bulk of today's session, which are on methods. There's a classical scientific method where you can observe some sort of phenomenon. It may be systematic, it could be occasional, it could be accidental. It's the thing that allows you to generate your idea first. You go, I saw this patient that had a really bad reaction to, I think, maybe this drug, right? And that might be just something that you observe. And then you have some idea of an explanation. So you might think, well, the drug was given on day 1, and the reaction occurred on day 3 or 4, so it's probably this drug and not 3 other drugs that were started 6 months ago. So you may have some idea of the explanation, and it's either through induction, conjecture, intuition, or even guesswork. You don't know, but you think it might be something. And it's usually informed by some related work. And your goal then is to take your guess, your best educated guess, and test it. And that's what a hypothesis is, right? It's an educated guess. And then you test it, and then you revise your question, and then you might have to retest a new question if the answer you get is not what you anticipate. So what exactly is a hypothesis, right? Well, the key thing about research is there's nothing certain about an answer, right? And oftentimes the exception proves the rule. You think it's going to be something, and it turns out it's not that at all when you systematically evaluate it. So scientific truth is usually a statement of what is most probable, given the currently known data and within the given framework. So in other words, answers are usually couched in terms of probability. Something is likely to be related. Something is extremely likely to be related, or something is unlikely to be related. But there's very few things that are absolutely certain when it comes to this. So we end up using statistical techniques to try to show us whether or the extent in which our results really do support the hypothesis. So a hypothesis really makes a prediction of the expected outcome in a given situation. It's your best educated guess. And usually, what we do is that we try to manipulate one variable, or the independent variable, and see how it will influence the behavior of a dependent variable. So oftentimes the independent variable for us in pharmacoepidemiology is giving a patient a drug. And then you want to see what happens to that patient, and that will be your dependent variable. Whether they get a good result, they get a bad result. Whether the drug is effective or it's not effective. Or whether the drug causes a bad reaction or no reaction. And then you have to ask a few questions. You want to know whether there is whether the independent variable influences the dependent variable. And that, you look for statistical significance in that case. But then you want to know, how much does it actually affect the outcome? How much does your independent variable affect your dependent variable? And that's the magnitude. And in what direction? Does it make does it make the cholesterol levels drop, or does it make the cholesterol levels increase, for instance? Does it drop the blood pressure, or does it increase the blood pressure? So you need to know not only significance, but magnitude and direction when you're coming up with your hypothesis. And the best educated guesses are not things in which you say, I think there might be an association. You want to say, I believe there is a strong association of this magnitude in this direction. And sometimes it is simply describing, the hypothesis may just be describing the relationship between variables, such as with correlation or association. So then you still want to know the significance, the magnitude, and the direction. And sometimes you're simply just describing a single variable. And the most common thing that we do as epidemiologists is we measure prevalence of disease. For instance, whether it's cancer or heart disease and so forth. And then we really want to know at that point, how precise is our estimate? And how different or similar is it from what you anticipated? So a classical way of actually testing is you want to find out, for instance, if the prevalence of lung cancer is over 20% in a population. So you basically use that as your hypothesis, your educated guess. And then you try to find out, I want that difference to be above 0. So you want your confidence interval around it to not cross over 0%. So when you're defining your hypothesis, you've got to think of significance, magnitude, and direction. And then you have to test your hypothesis. That's the whole point of systematic evaluations. So the experimental design ensures that what you're doing is genuine and solely responsible for the results. And then you try to control for extraneous variables. So these are your confounding variables that you'll be hearing throughout today's sessions. So part of what this first talk is to make sure that we're all using similar terminology throughout. Once you have designed your hypothesis, the next question is, what can you do with in terms of your experiment? So you can either choose to do something to somebody, such as a clinical trial in which you will be giving someone, for instance, a certain drug, or you're observing, you're doing an observation experiment where you don't actually get people to take the drug, but you monitor and see who takes the drug and who doesn't, and you follow it through. If the experiment works, regardless of whether it's an interventional or observational, the hypothesis is shown to be probably correct. You just can't prove 100% truth. If it fails, it could be because your hypothesis is wrong. Or maybe there's something wrong with the experimental design. The experimental design itself is faulty. So those are things to think about as you're designing your study throughout the day. I want to talk a little bit about null hypothesis. So when you do have comparisons, remember I've said that in some cases, the hypothesis may just involve giving an estimate of a value, in which case you're not comparing it with anything. But when you are comparing it with something else, then you want to set up your experiment to demonstrate or support your hypothesis. And the way you do that is to set up a null hypothesis. And that is to make an assumption that any observed changes in the behavior of your variable is due to chance and not due to your independent variable. The alternate hypothesis is then the fact that the correlation that you're trying to demonstrate is what is actually found. So our goal then is to best refute the null hypothesis, and therefore, if you can prove it's not the null hypothesis, it must be the alternative hypothesis is probably correct. And then you can say that with a measurable degree of likelihood. And that's how you come up with statistical significance. So where do hypotheses come from? It doesn't usually come from thin air. It usually comes from within a framework. So some phenomenon that's not well explained by current thinking, we just don't understand why some people are just not getting any benefit from drug A or drug B. And then in some cases, the new hypothesis is often an adaptation of some existing hypothesis. So someone found a relationship in mice, and so you're testing to see if this is how you explain the differences that you find in humans, for instance. The next thing I want to quickly talk about is what is a study? What's a research protocol? So this is really important because you are all going to be designing your study and research protocol today. So you need to know what it is, right? So to make sure we're all using the same definition, it's a systematic description of your research question and how you propose to answer that question. So it provides scientifically based rationale for all decisions related to every element of the research. In other words, it's a recipe. You're going step by step along the way. It has standardized elements so that anyone else following this recipe can replicate all aspects of your study. And when people understand step by step what you've done, then they can say, that's fabulous, I agree with you. Or then they can say, this is terrible, it's a horrible design. But until you actually write it all out, then you don't know if the cookies you're baking are going to taste good or not. In the same way, is your design going to be a good design or not a good design? And a lot of the problems occur when people don't specify clearly in the protocol what they're doing. So the protocol elements, at each of these steps, there should be a rationale. So this is a lot of what you're going to be discussing in the early part of the afternoon, is why you're doing certain things. So you want to know the background, the rationale. So you want to briefly describe the prior evidence, the study objectives, and the study aims. And I'll add something that's not on that slide. You want to find the gap in knowledge. You want to know what research question hasn't been answered that you want to answer. Then you want to talk about the study approach consideration. So you want to talk about the data sources, the study design, and the analysis plan. And then you want to look at the logistics. So then that way, you can deal with all the other aspects. For instance, is your study actually ethical? Could you actually do this? Is there a certain amount of quality assurance and data privacy that's involved? And it also lays out who's responsible for what. Are you responsible for certain aspects? Is your coordinator responsible for some other aspects? And it lays it all out. The fundamental similarities across all proposed research is that it tends to be hypothesis-based. Even if your hypothesis is not exactly specific. For instance, you're doing what we call a fishing expedition. You're just trying to catch a fish. You don't have anything specific in mind. Your hypothesis might be, I'm looking for some sort of relationship. I don't know what it is, but I believe my hypothesis is there is a relationship. As I said, it's better if you can also guess the magnitude and also guess the direction, but not always. It should be rationale-based, right? If you can't defend why you're doing this or why this question is important, why are you wasting your time writing a protocol? Why would anybody want to answer a question that nobody cares about, for instance? And then you want to lay out specific research aims. We'll cover that in a minute. And finding a niche or filling the gap of knowledge, as I mentioned before. You want to make sure that at the same time you've got expertise and that you're targeting an audience in this case. Because you don't want to write something that's just for anybody. You want to write for a reason. You're either writing because you're actually writing this proposal to try to get someone to give you money to do your experiments. So the audience is whoever's going to be looking at your grant to give you money. Or it may be to actually let people know what you're doing step by step. So the coordinators know what they're doing, for instance. If you can answer all of these questions that I mentioned in the previous lines, then you have a potential viable research question. And that is, these are the 4 questions that you should be making sure that you're asking throughout. What exactly is your question? Remember, a research question should be framed in the form of a question. What is your hypothesis? That is, what is your educated guess? What do you think the results are going to be? If you don't know and you have no clue at all, maybe you should go back and look at more data because you really should have some idea if you're proposing a question. Why or what is there a knowledge gap that you're filling, right? I mean, do you really want to do an experiment that 20,000 people have already completed and there are already 55 publications, right? So, and then finally, you have to explain why this is important. So if you can answer these 4 questions, then you may have a viable research question to move forward from. So how to determine if you have a good research question? Well, you gather background. So for instance, you look at things that people have previously published, what we call the groundwork. Then, in the green, you want to also, don't forget, to find out what people are studying right now. For those of us who've done research, it's probably happened to us, right? We just started to write our protocol, we've finished our protocol, we've submitted our protocol, and someone publishes on the exact same question, right? That's probably happened to more than one of us. So you have to be smart. So instead of just looking at publications, you also then, you want to talk to experts, people who are working in this field, to find out, for instance, is anyone working on this already? You want to look not only at the publications, but also at abstracts, at presentations and conferences like this one, because maybe you see some preliminary data that might make you realize, maybe I need to change my question because someone is already answering the question I'm interested in. All right? And then, again, with all of this, then you try to find this knowledge gap. So if you notice I'm repeating certain things over and over again, systematic approach, right? Clearly writing things out step by step like a recipe, and making sure that your question is important because it fills a knowledge gap. So how do you know if you should work on this research question? Well, once you've laid down the background and you think you've come up with a good research question. So in other words, you have a good project then, right? Don't forget, if you remember anything this morning, it's this triangle. Not only should the project be important, and that you can justify why this research question should be answered, but you also want to make sure that it's you and your team that should be doing it. Because I've got wonderful, wonderful research questions I have in my mind all the time, but they're in areas I have absolutely no expertise in. No one's going to give me money to do it. I don't have the patience to do it. I have no idea how to do it. I just have a great research question. That's not going to do. You must be able to have a team and the resources in order to do this. So as you're thinking about a research question, you've also got to think about what resources do you need and what team do you need. And for all of us, we all deal with team science. None of us go on to author papers as single authors. I think that's pretty rare. And so it's okay if you're not the right person, you can maybe even get a team of people that will be the right team, and you'll be one of the members, for instance, because you'll be the one that had the idea. So again, don't forget, this triangle is really important as you're thinking through today. So when you're thinking about how to then write a protocol and what elements are there, there are two ways of thinking about this. One way is those 6 questions, what we call the W5H, the 5 W questions, and then the 1H question. So the what, when, why, who, and where, and the how. Alternatively, many of you would have learned that you think about a protocol using the acronym PICO, P-I-C-O, or for many of us who actually deal with observational studies, P-E-C-O. The P stands for the patient, the population, and the problem. The I stands for the intervention. But for many of us, we deal with observational studies. So I replace the I with the E. It's the exposure, or if you call it the I, the variable of interest with the I. The C is a comparison, a comparator, or control, and the O is the outcome. So you need to be able to explain your protocol and the methods associated with each one of them, right? And if you follow the W5H, right, the Y is the background, and then the other 5 questions are all related to the methods. And for the design, I've basically gone through those methods as well. This is a template, a prototypical template that you can use to actually look at this. So it will include an introduction, a background, preliminary data, methods, but don't forget a timeline, a budget. You need to actually explain to everybody why your team is so important, and list equipment, resources, and the environment as well. All right, so you'll see aspects of this all the way throughout today, so don't worry, you don't have to copy this out right now. So a few other things that are important to finish up on is the fact that, what are the levels of plans? So if I ask you, what's an overarching goal of your study? What are the specific aims of your study? And what are the hypotheses? Will you actually know the difference between each of them? Because they are slightly different. The overarching goal is the overarching purpose of a proposal, and there should really only be one major one. Because if you have many of them, then that's actually different projects, right? There should be something that ties the project together. The specific aims are the experiments, the specific experiments and analysis that you're going to do to achieve this goal. And the hypotheses are basically your educated guesses for what would be the outcomes of each of the aims. So for instance, experts, the overarching goal might be to evaluate the role of certain genetic variants in predicting outcomes to a drug. The aims might be, number one, to determine whether an association exists between these genetic variants and specific outcomes, such as response rate or overall survival. And then the educated guess is, what do we think will be the results? So we hypothesize that certain variants will have better results than others, for instance. So this is just one way of thinking through as you're developing your protocol. So when you finish going through your research questions, ask yourself again, is this a good idea? So make sure you do your own research and seek advice from content experts. Is the project feasible? Do you have the materials? Are they available? Are they accessible? Is the data actually available? And you have to line up expectations and divvy up expected rewards for each team member as well. Because you want to bring people in to work with you, they have to each have a very specific role. And you also have to really ask yourself, am I the one to do this project? As I said, I've got great ideas, but some of them I'll never do. Alright, and then don't forget to also ask, who's on your team? What materials and resources do you need? What preliminary data do you need? Maybe this is not a great question, or this is a great question, but you've got the wrong methods. So you might need some preliminary data to help you. Who's going to help you check your writing? So you want someone senior who's done a lot of protocol or proposal writing, grant proposal writing, for instance. And is there someone or some group that's interested in funding this project, and who is the proposal's audience? So you can see that. A couple of other things then. There's really only one purpose of a background. Right? And the purpose of the background is to convince the reader that this is the most important research question in the world. That's really the primary goal of a background section. So identifying the gap and proving the importance. So for example, in this particular, in the example that I gave you, looking at whether genetic variants are associated with outcomes of a certain drug, then you might want to do a paragraph that talks about a summary of the disease, in this case colorectal cancer, CRC. You may want a summary of the drug. You may want to talk about the genetic variants and why they're important, and why this question is important. So this is what a student might be writing. The expert would actually, if you notice, convert this and actually answer a whole bunch of why questions, which is what the background information is all about. So why prediction of clinical outcomes in colorectal cancer is so important. So not just a summary of colorectal cancer, but focusing on the fact that predicting outcomes is so important. And then not just talking about the drug, as in the student for number 2, but actually talking of why this drug is such a great example to use for this cancer. Can you see? You're converting it all to ask why questions. And instead of just talking about the genetic variants, as shown in here, you're looking at the genetic variants and why they're so important, as why they are potentially important predictors of outcome. Can you see what I mean? And then don't forget, 2 other areas. Why is the trial or the study that you're doing the right one to do? And why are you the one to do it? And why is your team going to be able to deal with it? So in that way, you're covering both the project, the team, and the environment, that triangle. What's the role of preliminary data? I know it's very early, so maybe I'll call it a rhetorical question and answer it myself. So really the role of preliminary data is to show that you've done some of the work. It is one of the most frustrating things for someone who reads people's protocols, that sometimes you will read the entire background and they will say, so-and-so did this, so-and-so did that, so-and-so did this. And you don't realize until the end of the protocol. And then you're looking at their CVs, their curriculum vitae, the biographical sketches, and suddenly realize, oh my God, it's the team. It's the actual team that actually did all of the work. But you had no idea because they used third-person language, right? Now, so-and-so did this, so-and-so, and you don't realize that so-and-so is actually part of your team. So anything that you or your team does, you want to segregate out and list it as preliminary data. Because that helps people realize that you have expertise in this area and your team has already done a lot of the work. And so the only real difference between the background and preliminary data is background is what other people have done, and preliminary data is what you've done or what your team has done. So to come back again to this template then, if I were to insert the questions of the W5H, this is how I would do it. And I believe these slides will all be available at some point to all people here. But don't forget that there are other questions that you want to ask as well, like why us? How else can you do it? So limitations and alternatives. How much will it cost to do this? And why us, for instance? So with that in mind, I'm going to finish off by actually saying what's going to happen today. All right, so you've had a little bit of an introduction to developing a research question and the components of grant writing or proposal writing or protocol writing that hopefully you'll use for the rest of today. You'll be learning about study design and methods for the rest of this morning. There'll be 2 tracks. Those of you who are in the database track will go next door, and those who are part of the non-database track will stay here. And in the afternoon, we're going to actually put it all together by writing a protocol and study proposal.